Here we have a graphical inequalities question involving a word-based question for GCSE, and you have to construct your own inequalities statements from the words they're given you. It says a greengrocer sells bananas and apples. In one day he sells up to 80 bananas, up to 90 apples, and no more than a total of 110 pieces of fruit. Let X be the number of bananas and Y be the number of apples sold. So X is bananas, Y is apples. One day he sells up to 80 bananas. When it says up to, that means not including. So X is bananas can be up to, which means less than, but not equal to, so just less than 80. Similarly for apples, which is Y, is less than 90. Let's put the 0 on the 80. And then it says no more than a total of 110 pieces of fruit. So that means together they cannot equal more than 110. So X plus Y is less than or equal to 110 because it says no more than. So now we have three inequalities conditions and we can graph them on the chart below. So let's do this relatively quickly. X is less than 80. We need a dotted line going through X equals 80. So there's X equals 80, and we're going to do a dashed or a dotted line through there. Now, if X is less than 80, we need to shade anything greater than 80 to show that that's unwanted. Just as long as you are actually indicating the wanted region, usually by indicating with an R, that's sufficient, usually sufficient. Now the next part is Y is less than 90. There we go. So where's Y equals 90? Right there. Let's draw another dashed line through there and get rid of our ruler for now and shade above that because we know that the value is less than it. And then we have one more line to draw, and that is X plus Y is less than 110. Let's just change it so that this Y is less than negative X plus 110. This is now our y-intercept, positive 110, and our gradient is negative 1. We've seen this a few times now already. So we find y at 110, and we go a negative 45 degree angle. From 110, negative x. In this case, it was less than or equal to. So this is the tricky part. It's not always the region in the very center. If it says here y is less than or equal to, that means this region below is wanted or possible. So we can only shade above this region, and we know the wanted area remains down below. So again, I would recommend you make it very clear that this is R, and I would actually indicate this as well. This is R and there's R. So that's our region where the conditions are all met. The next one here actually requires you to determine the formula for the lines and then work out whether this region is above or below it. So why don't we do that? The first one, let's just do this line here. Let's label this line with the actual formula for that line. We go y equals mx plus c. What's c? Well, it's the origin. I'll go down here. So we're going to be y. I'm just going to keep it as equals to start off with. I'll start with plus 0. And what's the slope? Well, if I go up 2 and I go across 2, then our slope we can see, it's 2 over 2, which is just 1. And so it's 1x. That simplifies to y equals x. It's a solid line, which means that y and the r is below it. So that means that y is less than or equal to x. That's our first one. What's our second one? So let's choose this one here. This one should seem a little simpler. This is where x equals 6. And so our line is just x equals 6. Now, where's the region that we want? It's below that. It's where x values are less than 6. So x is less than or equal to, because it's a solid line, 6. And finally, in green, this dotted line here. Dotted line means that it's going to be either less than or equal to. I hope you can already see that the region here is above it, so we're going to talk about greater than, and we're talking about a value on the y-axis, a horizontal line, so y equals 2 here. So the actual inequality would be y is greater than 2, not equal to. So finally, just to make sure it's nice and clear, y is less than or equal to x. X is less than or equal to 6, and y is greater than 2. And you're done.